Hello, welcome to my channel Tech by Sensei Kushal. In this session, we'll understand the design patterns. I am creating a short video series where I will be explaining all the design patterns available in the market. So let's start the session. Before starting the session, I request you to subscribe to my channel Tech by Sensei Kushal. So let's start the session. So let's understand what is design patterns. So a design pattern is essentially a proven solution to a common problems encountered in a software design. Understand an example. There has been some issues when you are designing a system. Okay, there can you can take a multiple approach and you can solve that problem. Okay, so our previous developers in the history they have come up with a problem, and to resolve those they have created a standard approach to resolve those problems. So these standard approach are called design patterns. Okay, so these pattern provides a standard approach to solve the recurring design challenges, making a system easier to understand, modify, and maintain, right? They act as a blueprint, offering general reusable solution that can be adapted to a specific problems without reinventing the wheels. Okay, so you don't need to reinvent anything for a particular set of problem. There is a particular set of solution. You can implement one of the design pattern to solve that problem. Here, one thing to note is that you can implement a combination of design patterns as well in your application. It is not mandatory to implement only one design pattern. To one section of the application, you can implement one design pattern. In the another module or in another section of the application, you can implement another design pattern. It's up to you how you want to design the application. Okay. Coming next, why we need the design patterns. There are few pros of using a design pattern in applications. So let's understand that. First is code reusability. Design patterns offer solutions that can adapt to different projects, reducing duplications of efforts and saving development time. The next is improve code quality. By using a design pattern approach, your code becomes more robust, modular approach, then reliable and less prone to errors as well. Then better communication. So if you are communicating with stakeholders, customers, or inside your company to peer also, then if you are implementing a design pattern, it is easy to convey or to explain to them like why we want to design the system in this way. Okay. The next one is simplifies maintenance. It helps to create modular and flexible code, which is easy to debug, test, and extend to the requirement evolutions. Okay, you can create multiple modules out of it in this way. The next one is promotes good practices. Obviously, this design pattern encourage consistency and best practices, making the code base easier for new developers to understand. And you can pass on the knowledge by to the new developers in the team. Okay. Efficient problem solving. By addressing recurring challenges with established solutions, design pattern accelerate the decision making in a complex project. So, as I can say, these design patterns help to resolve the problems which are already solved. So, you don't need to uh, think of that problem and to come up with a new approach. You can use already present or already resolved these patterns so that you can resolve or you can focus on the more complex part of the project, not the basic parts of the project design. Okay. So there are few categories of design patterns. Okay. The first category is a creational pattern. Okay. The second one is structural pattern, and the third one is behavioral pattern. So first come the creational design pattern. So the purpose of the creational design pattern is to simplify and manage the process of object creation in the software application. Okay. So how object will be created will be designed by these type of design patterns. Okay. So what they do, they help you make your system more flexible, scalable, and maintainable by abstracting the object initialization process. Okay. So the second one is structural design pattern. So this design pattern is helps you to simplify the design and structure of the system by defining the relationship between object and classes. Okay. So the Pattern focuses on how object and class can be combined to create a larger or more flexible and structure of the application. It also ensures the efficiency and maintainability of the system. Okay. Behavioral design patterns. So these pattern helps to manage and define the way the object interact and communicate with the systems. Okay, or the object interaction between them and the communication with the system. Okay, these patterns focus on improving the collaboration, responsibility, and flow of control between the objects. Okay, and they also enhances and the flexibility and scalability of the system. So it is easy to understand and easy to maintain as well. Okay, so let's start with creational design patterns. We have this much of design patterns under creational design pattern category. Okay, so the first one is a singleton design pattern. In this design pattern, it ensures class can have only one instance and provides a global access point to it. Okay. So these are used when you want to create some database instances. Okay. So you don't want to create a multiple database object. You can use the one object and you can use it in the entire application or in the entire module. Okay. The second one is the factory method. This method defines the interface of the for the creating objects, but allows subclasses to alter the type of objects they are created. Okay. The third one is abstract factory design pattern. In this pattern, it creates the family of related objects without specifying their concrete class. Okay. It's like abstracting objects and creating the new classes, right? The builder design patterns. So this design patterns provide step-by-step approach to construct a complex object. Okay, if you are creating a complex object, then the design pattern works for you. And the last one is the prototype design pattern. So it allows cloning of objects. So you can clone one object and you can define your method on the top of it. You can also use the parent methods as well, define of the parent object. But after prototyping, you can use the client or the child object as well. So next one is the structural design pattern. We have this much of a design pattern under structural category. Okay. So for structural design pattern, first one is the adapter. So as name suggests, it enables the incompatible interfaces to work together by acting as a bridge. Okay. So this work as a bridge. Okay. So the next one is the decorator design pattern. So it's dynamically add responsibilities or behavior to the object without altering their structure. Okay. The third one is facade or facade. It provides a simplified interface to the complex subsystems. Okay. The fourth one is the composite design pattern. Creates individual object or a group of objects in a unified way, especially in a tree-like structure. So if you have a tree-like structure for your design for your system, then this composite design pattern you can use. Okay. The next one is the bridge design pattern, decouples an abstraction from its implementation, allowing them to vary independently. Okay. The second last is the proxy design pattern. It provides a placeholder, or you can say it's like a surrogate for another object to control access to it. Okay. Like the proxy settings. Okay. The last one is the flyweight, reduces the memory usage by sharing the common data between similar objects. So the similar objects can share the common data. So in this way, you can reduce the memory usage by the system. Okay, the next design patterns are behavioral design patterns. So under this, the first one is a strategy design pattern. So this defines a family of algorithms, encapsulates each one and makes them interchangeable. Okay. The next one is observer design pattern. So this establishes a subscription mechanism so that the multiple object can notify of the changes to another object state. Okay. The third one is the command. It encapsulates requests as objects, allowing for parameterizations of the client and queuing or logging of the request. Okay. The fourth one is the chain of responsibility. So this design patterns helps in API REST APIs implementation many of the time because this design pattern delegates the request to the chain of handlers until one of them processes the request. Okay. A state design pattern, it allows an object to change its behavior when its internal states change. Okay. The next is the template method design pattern. In this design pattern, it defines the skeleton of an algorithm and lets subclass fill in the specific steps. Okay, it's just the skeleton of the algorithm. The inner part of the internal working, you can do it by yourself using the subclass steps. Okay, so this is how this works with the template method design pattern. A mediator design pattern, it centralizes the complex communications between the objects, and it also avoids the direct dependencies between them. Okay. The last one is the iterator behavioral design pattern. So this provides a way to access elements in the collection sequentially without exposing its underlying structure. Okay. So these are the behavioral design patterns as well. Okay, so this is it for this session. In the next session, we'll dive into each of these design patterns in depth, and I'll be showing some code how to implement these design patterns. So stay tuned with us. We'll be putting a lot of efforts to create this video. So if you have any queries, you can comment in the comment box and let us know. Like if you want to more design patterns included in this series. We'll happy to help and create videos for you. Thank you.